All right, so this is the second answer video. Let's see. So we're looking over here, and what problems did we give you? Okay, nothing there, nothing there. Okay, we can start right here. So we got what's my amplitude, my frequency, my period, my phase shift, and my vertical shift for this problem. Y equals -3 sine 2 times x plus pi. Let's get it right. Okay, plus pi minus 4. Okay, so the amplitude, remember, amplitude is your first number. It's y equals, just like it is over here, a sine of b x. That's not plus, it's supposed to be minus c plus d. So my amplitude is a, and a is always positive, so that's a +3. Frequency, that's b, it's right in the right spot, so that's 2, right? And then period, that's 2 pi divided by b. So that's going to be 2 pi divided by 2. The 2's cancel each other out, and I'm left with pi. So then phase shift. Phase shift is the opposite of what I see here. That's plus pi, so then that's going to be negative or minus pi. And then the vertical shift, that is a -4. Vertical shift is what you see is what you got. So -4, so -4 is what I pick. And that's my answer. So 3, 2, pi, -pi, -4. Bada boom. Okay, we got some sines here, and we got some cosines. So this is talking about what if it's more than 360 degrees. Remember, 360 degrees is a complete circle. That's also 2 pi. 2 pi is a complete circle. It's in radians, and that's degrees, right? And so if I'm saying sine of 925, I need to say sine of 925. So I need to subtract 360. That's one complete revolution, one complete circle. So let's see, 5, get 8, to 6, and 5. Oh, that's still more than 360, so I subtract again. See, 5, 0, 2, 205. Well, 205 isn't on my chart. So that was a bad read, I guess. Definitely not stopping this video. I must have miscalculated somewhere. No, let's see, 5. I gotta borrow, make that 8. So that's 12, 6, yeah, so that was fine. 205. That's interesting. Well, worst comes to worst, I could always put it in a calculator. I'm not gonna do that. We are going to, let's say we just gonna fudge the numbers, and we're gonna say, we take 360 away again, and we end up with 225. And so now that is under 360. So now I can use my chart to find it. So 225 is right here, and I'm going for sine. Sine is a second value. That would just be um, negative square root of 2 over 2. Now, obviously, that's not the right answer because we had to do a little fudging. But that's the process, is that you're given some value and you're going to keep subtracting 360 until you get a number that's under 360. And then you can use your chart. Because all that's happening is you're starting at this 0 point. Starting at this 0 point. And so you go around, you make it all the way, one whole revolution, 360 degrees. And then you start the whole process over again. and you go another 360 degrees, and you start the whole process over again. And these values don't change. They're still there. All right. So every 2 pi that you go, every 360 degrees that you go, you start over again. So let's see what 5 cosine of 5 pi gives us. Well, 5 pi, I know that 2 pi is 360 degrees. So that's 1 revolution. So I subtract, and I got 3 pi. So I do it again. I subtract 2 pi, and I'm at pi. So see, pi is less than 2 pi. So I can find pi. So we went 1 revolution, went 2 revolutions, and then we went zzz, right here. What's my cosine? -1. So that's -1. Let me see, what was I thinking when I did that? 720, 925, 205. Yeah, I was thinking what? I was thinking maybe 135, or I was thinking 225. Should have been 945. I messed up. That's what should have happened. That should have been a 4, not a 2. Well, anyway, I want to make sure you get the gist. Okay. You keep subtracting 360, or you keep subtracting 2 pi until you get something under 360 or under 2 pi. Then you take the sine or cosine of that from your chart. Let's see. So that one was a little of a bust, but other than that, we're okay. All right. So here's what we got going on. I got sine, cosine, tangent. That's SOHCAHTOA. And then I've got cosecant, secant, and cotangent. These are the reciprocal operations. Because if you look, the side opposite and hypotenuse, hypotenuse over side opposite. The side adjacent over the hypotenuse, hypotenuse over the side adjacent. Side opposite over side adjacent over opposite. So that's from the context of this spot right here. See, opposite side of that spot. If this is my reference point, that's the opposite, that's the adjacent, that's the hypotenuse. So here, let's find the cosecant of A in this case. Well, what does it say? Cosecant says hypotenuse over side opposite. The hypotenuse is the longest side, so that's 5. And then the side opposite, my A here, is 3. So it'll just be 5 over 3. And then what is the tangent of B? So see, this flips the script. Now I'm looking from this reference point. Tangent says you go the opposite side, then the adjacent side. So that's 4 over 3. What about radians to degrees? So I've got 3 pi over 4, and that's radians to degrees. So that means I want to multiply by 180 over pi. I know that because I'm starting with pi and I want to get rid of pi. Excuse me. So the pi's cancel each other off. I get 1, and 3 times 1 is still 3. So that's just going to go away. That's going to be a 1. So I can either multiply 3 times 180 and then divide by 4, or I can divide by 4 and then multiply times 3. And that's what I'd rather do. So I'm going to divide by 4. That gives me 1. 4 goes evenly into 180. I just happen to know that. So 4 goes into 18 4 times because that's 16. 16 minus, or 18 minus 16 is 2. So then that gives me 20. 20 divided by 4 is 5. So I got 3 times 45. And that gives me, let's see, 5 times 3 is 15, carry to 1. It's 12, 13. That's 135. Now, I'm sure if we just looked at the chart, we could find that. What about 780? I got 780 times pi over 180. So that is 780 over 180 times pi. So the reason I write it like this, because you could write the pi up here if you want or not. The thing is, though, I need to reduce, and that pi doesn't have anything to do with me reducing at this point. So that's why I just kind of write it to the side. So because it's like it's going to be multiplied. It's like pi over 1 times this. So first I can divide by 10. That gets rid of the zeros. When we cancel off zeros, it's because I'm dividing by 10. I don't just cancel off zeros because I want to. Okay, I'm canceling off zeros because if your number ends in 0, you can divide it by 10. So that's what we did. We divided by 10 top and bottom. So now I got 78 over 18. Well, let's see. If I go back to this page, are those both even numbers? Yes, they're both even numbers, so I can divide by 2. Does the trick for 3 work? Well, 7 plus 8 is 15. 15 can be divided by 3. 1 plus 8 is 9. That can be divided by 3. So, yep, so 2 and 3 work. Well, then that means 6 work. 6 works if it's even and divisible by 3. If 2 and 3 can go into it, then 6 can go into it. Don't think 9 can go into it because that doesn't line up with 7 plus 8 is not divisible by 9. So we can divide by 6. So let's do that. That's all the process is. You start with 2 and you work your way down. And you don't necessarily have to work your way all the way down because I could have looked at 780 divided by 180 and just started dividing by 2. What have I told you about mathematicians? We're lazy. We don't want to divide 20 different times, maybe 2 or 3 at the most. 78 divided by 6. 6 goes into 7 one time with 1 left over. 6 goes into 18 3 times. 6 goes into 18 3 times. So my answer for this one is 13 over 3 times pi. Okay, let's see what's next. There's nothing to do there. Okay, there is something to do here. Clean slate. Okay, I need to find a guesstimation or estimation of log of 1400. Well, 1400 is 2 times 7 times 100. Now, why did I choose those numbers? Because those numbers are right here. I could have chosen other numbers. I could have, but what use is it to choose other numbers when those numbers aren't right here in front of me? So that's why I chose these numbers. There's 2, there's 7, there's 100. So now that was nothing. I'm going to use rule 1 for this. So I'm going to say log of 2 plus log of 7 plus log of 100. And remember, because there's no base, what's the base? Is 10. So that's going to be 0.3010. That's going to be 0.8451. And then this is going to be 2. And so excuse me, 6, 4. So that is going to be 3.1461. That's my answer. Okay, let's see what else we got. Okay, I don't think we've got that. Not that, but we got a problem here, so let's do that. Okay, 150 students were surveyed, whether their family had a pool and if they owned a cell phone. So we know that our total is 150. 135 students own a cell phone. So I just look at the column or a row that's talking about cell phone, and that's it. 135 students. Notice they didn't get anything specific. They just said 135 students. So that's letting me know that that's the total, right? And then I've got 11 students don't have a cell phone and their family doesn't have a pool. So doesn't have a cell phone, doesn't have a pool. That's where they meet right here, and that's 11. Now, I said that box because this said doesn't have a cell phone and Their family doesn't have a pool. If 22 students have a cell phone and their family owns a pool, so that's right here, that's 22. How many students' families do not own a pool? So now I want to know the total. How many just don't have a pool? So there's a few things that I can do here. I've got enough information to get all of the stuff. So like from right here, I can figure out what number goes here, right? I can figure out what number goes right here. I can take 150 and subtract 135. That should be what, 15? So that means 4 has a pool and don't have a cell phone, which is crazy. What they got a pool and they don't have a cell phone for? Well, I mean, I take that back. Your family can have a pool and your little tail don't deserve a cell phone, so whatever. Anyway, 135 minus 22, so I need to figure this one out real quick. So let's see, that's 311, and then I can add or subtract across. So I'm gonna add, that's what, 26, and then that's 124, and those add up to be 150. So how many students don't own a pool? 124 out of the ones that they surveyed. That's a lot of folks that don't have a pool. Out of 150, oof. Okay, what is the relative frequency of the students who own a cell phone? Relative frequency is talking about taking your number here that's in the chart and dividing it by the total number of people that were surveyed or that you looked at. This box right here. So the students who own a cell phone, that's the total because they don't get specific about having a pool or not. So that's 135, and that's going to be divided by 150. I don't know that off the top of my head, so let's figure it out. 35 divided by 150. So that's 0.9 or 90%. I would accept either answer. All right. What is the relative frequency of the students who don't have a cell phone and their family doesn't own a pool? No cell phone and no pool. That is 11 over 150. And so we need to do the same thing. Whoa. So that is 0.7 repeating 3. I'm going to stop right there because see this 3 right here, it doesn't cause this 3 to go up. So I can just stop right there. Now, whoops, I'm sorry, I screwed up. Yeah. Make sure you're reading and writing this stuff correctly. 0.073 or not 0 or 7.3%. And that's my answer there. See what else we got. Percents. Don't see anything that we need to do there that we skipped over. Don't see any problems there. Don't see any problems there. I think that's the end of the line. Okay, so that's all of the stuff. I'm going to post this second video, and that will be that. See you Monday.